The goal of the ASHRAE Integrated Sustainable Building Design is to design a self-sustaining meteorological station. The idea is to design a building that is able to give the best return on investment after 50 years, and it has to satisfy the ASHRAE standards as well as the owner requirements.
Renewable energy is how we are achieving our net zero goal. The idea is to build a building that generates as much energy as it uses without any carbon being emitted in the process. The overall system that we came up with used solar, wind, it has a connection to the grid, and then we also have it hooked up with a propane generator backup.
The building site is located on a 94-acre island between the southern tip of Chile and Antarctica. The way we figured out what the best envelope was is we first simulated a 90.1 2016 baseline. Once the baseline was established, we ran a simulation on that, and that gave us a base to compare everything against. From there, we changed one material at a time and ran simulations, and that way we could know what each changed, how it affected the heating load and subsequent energy efficiency. So one of the most important things about the building envelope is the foundation. Because the earth is cold there, the more that you increase the insulation value, the more energy savings you see. So for the walls of the building, we tried 5 different types. So after running simulations on each wall type to see how much energy each one used on an annual basis, we found that the wood frame wall with the continuous insulation on the outside was actually the most efficient. For the roof, what we did is we tested everything against the baseline. We found out quickly that you don't have to improve the roof at all over 189.1. It's good enough as is, just build it like that and you're good to go. So after we ran simulations and found out what the best building envelope materials were, we put them all together into a single model, ran the simulation again, and proved a full 30% savings in energy. That 30% savings in energy, even when considering the additional initial cost of the more expensive building materials, will save the owner $725,000 over the life of the building.
So one of the main components of the building is sustainability. One of the things that we looked into was light pollution, the heat island effect of the building, and the recyclables, like the locations where we were going to have recyclable bins in the building. And finally, it was the shading and how that was going to impact the heat island effect.
My responsibility was to meet ASHRAE 189.1 indoor environmental quality, which includes ASHRAE 62.1 on ventilation and ASHRAE 55 with thermal comfort. So the radiant system is a tubing, polyethylene tubing that's inside the slab, where it moves water through the tubing, and since water has a higher coefficient of heat transfer, it uses less energy, and therefore it'll be better for the customer to have a better 50-year lifespan return on investment. So the dedicated outside system, what it does is it brings in 100% of outside air, it pumps it into the occupied spaces, and it takes all that air and pushes it back out. The DOS system controls the humidity in the occupied spaces, and then the radiant system, it controls the temperature, it keeps the occupant satisfied.
So for the water use efficiency, we first look at the standards, and then we look at the resources on site to see what we can use to reduce the water consumption even more. By looking at the climate, we noticed that there's a lot of rainfall. So in order to reduce the amount of water used on site even more, we're going to use the rainwater harvesting to reduce our overall water consumption, in addition to WaterSense products and Energy Star appliances. So for our rain harvest water system, we first collect the water and it goes through an initial filter. After that, it gets stored into a cistern. Then the water can be used for gray water for flushing. Now, if you want to do more to those collected rainwater, it would go through another filter, a 5-micron filter to be precise. After that, it would have to go to a UV purifier, and then it can be used for drinking water, it can be used for the cold water supply, to shower, or anything you can think of.
Simulations were used to determine the best lighting environment for the building, and we compared different lighting fixtures like fluorescent, incandescent, and LED. We used the standards to be able to use which power densities were appropriate for each zone. Based on that, LED were the ones selected. So for the external lighting, one of the things that we needed to have in mind was light pollution, and we based our selection based on the standard for the International Dark Sky Association. So the light fixtures that were chosen needed to meet those standards, and most of the lights are going to have their LED light, and they're going to have motion control where they would turn off automatically if there was no one there.
USGBC, United States Green Building Council, a relatively new organization in standard setting, spearheaded a program called LEED, and it's Leadership in Energy and Environmental Design. And it has given a very easy metric to measure how green, how sustainable, how energy efficient a building is. There were a lot of points within LEED that we simply had to take a punt on. There was no way we could make a claim for them because of our location. There's a lot to do with LEED that really aims at building a more sustainable community in an urban area, and we are in the least urban area you can possibly imagine. For sustainable sites, we had to look really hard at the environment that we were on, and that includes some endangered species. We have albatrosses, brown albatrosses, that are genuinely an endangered species, and we're talking about putting windmills up to generate our electricity. And almost anyone that pays any attention to renewable energy knows that there's a loud outcry from the environmental community against turbine use in high traffic bird flying areas, because it does take some of them down. To mitigate that, to reduce that, to make sure we're not killing any of these endangered species from sunup to sundown during the times of year that these albatrosses are migrating, we're going to shut down our wind turbines. We're going to make sure they're not running, and we're going to keep these birds safe, while also supplying renewable energy to our building. There's always a compromise, there's always a way to make it work, and we found that way. Energy and atmosphere. Again, our renewable energy resources, we have covered the gambit. We have a completely renewable system that has absolute backup and will never shut down. And any time that we don't have renewable resources, we've developed a plan to purchase carbon offsets so that we can trade the carbon that we do use with other groups that are greener and sustainable and have extra to trade. And we can make sure that the balance on the globe is met through those cap and trade and through that carbon offset purchasing program. Indoor environmental quality with our building automation system, with our intelligent HVAC design, with our radiant floors, we are adamant about ensuring the comfort of all of the occupants in this building. We have exceeded ASHRAE 55.1, whether you're talking about the performance option or the prescriptive option. We have exceeded it in every regard, and we're able to claim the vast majority of the LEED credits there. We missed one or two there, again, because of our location-specific problems. The innovation credits were personally the ones I was most excited about getting, because it meant we were thinking about the problems in a new way, and we were able to tackle LEED certification with imagination and zest. we have put in a lot of hours into this project, and I really have to say, as we're walking away from it, we've put together a good building. This is, aside from all the ticking of the boxes to make sure we hit the codes, this is an energy efficient, sustainable design that would serve these customers well beyond the lifespan that they specified.